Jessica.
We were hunters and foragers. The frontier was everywhere. We were bounded only by the earth and the ocean and the sky. The open road still softly calls. Our little terraqueous globe is the madhouse of those 100,000 millions of worlds. We who cannot even put our own planetary home in order, riven with rivalries and hatreds, are we to venture out into space? By the time we're ready to settle even the nearest other planetary systems, we will have changed. The simple passage of so many generations will have changed us. Necessity will have changed us. We're an adaptable species. It will not be we who reach Alpha Centauri and the other nearby stars. It will be a species very like us, but with more of our strengths and fewer of our weaknesses. More confident, far-seeing, capable, and prudent. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness. What new wonders, undreamt of in our time, will we have wrought in another generation, and another? How far will our nomadic species have wandered by the end of the next century, and the next millennium? Our remote descendants, safely arrayed on many worlds through the solar system and beyond, will be unified by their common heritage, by their regard for their home planet, and by the knowledge that whatever other life may be, the only humans in all the universe come from Earth. They will gaze up and strain to find the blue dot in their skies. They will marvel at how vulnerable the repository of all our potential once was, how perilous our infancy, how humble our beginnings, how many rivers we had to cross before we found our way. We were hunters and foragers. The frontier was everywhere. We were bounded only by the earth and the ocean and the sky. The open road still softly calls. Our little terraqueous globe is the madhouse of those 100,000 millions of worlds. We who cannot even put our own planetary home in order, riven with rivalries and hatreds, are we to venture out into space? By the time we're ready to settle even the nearest other planetary systems, we will have changed. The simple passage of so many generations will have changed us. Necessity will have changed us. We're an adaptable species. It will not be we who reach Alpha Centauri and the other nearby stars. It will be a species very like us, but with more of our strengths and fewer of our weaknesses. More confident, far-seeing, capable, and prudent. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness. What new wonders, undreamt of in our time, will we have wrought in another generation, and another? How far will our nomadic species have wandered by the end of the next century, and the next millennium? Our remote descendants, safely arrayed on many worlds through the solar system and beyond, will be unified by their common heritage, by their regard for their home planet, and by the knowledge that whatever other life may be, the only humans in all the universe come from Earth. They will gaze up and strain to find the blue dot in their skies. They will marvel at how vulnerable the repository of all our potential once was, how perilous our infancy, how humble our beginnings, how many rivers we had to cross before we found our way. Consider again that pale blue dot we've been talking about. Imagine that you take a good long look at it. Imagine you're staring at the dot for any length of time. And then try to convince yourself that God created the whole universe for one of the 10 million or so species of life that inhabit that speck of dust. Now take it a step further. Imagine that everything was made just for a single shade of that species, or gender, or ethnic or religious subdivision. We can recognize here a shortcoming, in some circumstances serious, in our ability to understand the world. Characteristically, we seem compelled to project our own nature onto nature. Man, in his arrogance, thinks himself a great work, worthy of the interposition of a deity. Darwin wrote telegraphically in his notebook, "More humble, and I think truer, to consider him created from animals." Close quote. We're Johnny-come-latelys. We live in the cosmic boondocks. We emerged from microbes and muck. Apes are our cousins. Our thoughts and feelings are not fully under our own control. And on top of all this, we're making a mess of our planet and becoming a danger to ourselves. The trapdoor beneath our feet swings open. We find ourselves in bottomless free fall. If it takes a little myth and ritual to get us through a night that seems endless, who among us cannot sympathize and understand? We long to be here for a purpose, even though, despite much self-deception, none is evident. The significance of our lives and our fragile planet is then determined only by our own wisdom and courage. We are the custodians of life's meaning. We long for a parent to care for us, to forgive us our errors, to save us from our childish mistakes. But knowledge is preferable to ignorance. Better by far to embrace the hard truth than a reassuring fable. Modern science has been a voyage into the unknown, with a lesson in humility waiting at every stop. Our common sense intuitions can be mistaken. Our preferences don't count. We do not live in a privileged reference frame. If we crave some cosmic purpose, then let us find ourselves a worthy goal.
Is the universe still expanding fast? I mean, is there a lot more room in space, as I think of it, for the universe to carry on getting bigger?
As far as I know, nothing in the way, and the expansion continues. The question is whether there is sufficient matter in the universe, matter that we have not yet counted, that will slow the expansion down, stop it, and have the expanding universe followed by a collapsing universe, or whether there is not enough matter to stop the expansion, and so the expansion then continues forever. This is an observational question which is still unresolved, and the Hubble Space Telescope, which who knows might be launched next year if we're lucky, might answer this question.
Professor Hawking uses a very striking metaphor of the Earth borrowing its energy from itself. Now, in straight banking terms, that means you're going to be overdrawn, and in the end there's going to be a collapse, a big crunch. So does Big Bang get followed inevitably by Big Crunch?
No, not inevitably. It depends on how much matter there is in the universe, which is a still unsolved issue. I should say that the prevailing opinion is that the universe will continue expanding forever, but that, in my opinion, is by no means a very secure conclusion.
Well, let me bring in the poet amongst us here. Arthur Clarke, you know what T.S. Eliot said, "This is the way the world ends, not with a bang but a whimper." When you think of the end of the world, if you think of the end of the world, does it end with a bang or a whimper?
Well, one would like to think that we will end with a bang. Of course, we'll never know. It is rather a long way in the future. Some billions, tens of billions, possibly even much further in the future. And as Carl said, we may have the answers to these questions in a very few years if the Hubble Space Telescope gets successfully into orbit and can peer out to the boundaries of the universe.
If we are sort of living in a little suburb of the galaxy, can you foresee a time when we'd need to get out of the suburb and colonize somewhere else because of the gradual curve towards the end?
Well, I think the human race, if it survives the next few years, will go on to colonize first the solar system and then to send ships out to the stars and ultimately perhaps to other galaxies. But if the expansion of the universe is fast enough, we will never be able to keep up with it.
Now, one fascinating aspect that is raised is the question of time itself in the book. Now, we all think that we know what time is. It's a relentless march forward. But for the purposes of your argument, Stephen Hawking, you use a mathematical concept that you call imaginary time, which seems to be able to run backwards as well as forwards.
In our theories, there are two kinds of time. There is what is called real time. This is the kind of time that is measured by a clock. The time that we feel passing, the time in which we grow older. Then there is imaginary time. Of course, imaginary time is an idea that science fiction writers, like Arthur, have used in their stories. But imaginary time is also a well-defined mathematical concept. It can be thought of as a direction of time that is at right angles to ordinary, real time, in a certain sense. The universe has a beginning in real time, at the Big Bang. And it may well have an end if it collapses to a big crunch. But in imaginary time, it has no beginning or end. Rather, imaginary time is closed in on itself, like the surface of the Earth. The surface of the Earth doesn't have any beginning or end. I know, because I have been round the world, and I didn't fall off. Individual particles can travel through imaginary time and arrive back at an earlier real time. But I don't believe that people will ever be able to travel back in time, like in the film Back to the Future.
I'm going to come first, if I may, to you, Carl Sagan, because this idea in Professor Hawking's book, this extraordinary four-dimensional model of the universe with no boundaries, but finite, just like the Earth. This, to me, is really stretching my own capacity for imagination to the utmost. How would you turn it into words for me, a layman?
Well, the first thing I would say is not to feel bad if it's not immediately, intuitively obvious. Our ability to understand things instantly, so-called common sense, derives from a certain range of size and speed and duration that are appropriate for human existence. We know about things from 1/10 of a millimeter to a few kilometers, from a fraction of a second to a lifetime, and so on. So when we are dealing with matters of quantum physics, where particles have a size of 10 to the minus 13th centimeters, or in cosmology, where we are talking about 10 billion light years or more, it is very reasonable that our intuition is not adequate to the task. One point I'd like to make about this is that every human culture has a set of creation myths, but they're in the realm of mythology or religion or folklore, and they are, of course, all mutually inconsistent. The great thing that is happening in our time is that we are able, through a method which can actually make some progress towards the real universe out there, to find out something about origins, and this is the scientific method applied to the science of cosmology. So I know that's not a direct answer to your question, but I thought it was more important to address the issue of feeling unhappy because it wasn't immediately understandable.
Well, yes, I find that extremely soothing, actually, because it is a kind of sort of formidable task of grasping this. It makes me want to retreat into trivial questions like, is this idea of predicting backwards going to put astrologers out of business?
Nothing will put astrologers out of business.
Well,
alas.
Well, that certainly added a touch of lightness to these tremendous issues that we are discussing: infinity, black holes, and imaginary time. And at this stage, let's relax a little bit and have a bit of fun with mathematics at their most abstruse. I'm going to ask Arthur Clarke here to do some doodling with his computer and with a fascinating exercise with complex numbers, which is called the Mandelbrot set. Now, this is named in honor of a French scientist working for IBM. It's a mathematical equation which leads us towards the infinite. In effect, it makes the mathematics of the universe visual and incredibly beautiful. This is what we would see if we had eyes to see it, when order meets chaos. This is what's going on in the universe every day. An ordered universe is breaking down and becoming more disordered. This is the second law of thermodynamics in action, what Stephen Hawking calls Murphy's Law. Now, Dr. Clarke, you've been using your computer back home in Sri Lanka to explore the Mandelbrot set at incredibly high magnifications. Over to you, sir.
Yes, well, this strange-looking object is the Mandelbrot set, which actually is extraordinarily simple in concept. It's defined by an equation of just two terms, z squared plus c. That's all there is to it. Yeah, that simple equation, z squared or z squared plus c, you feed a number into it, then carry on over and over again, sort of cranking the number back round and round, and then plot the result on the screen. So I won't go into details, but this is the first appearance of this set. And what it does, it divides all possible numbers into two categories. It's really a map or a boundary or a fence, if you like, dividing one class of numbers from another. And you can tell your computer to go into any spot here and say, recompute that area to a higher degree of precision, and then blow it up on the screen. So you can use the computer as a microscope, and you can continue that process forever. Some of the images are incredibly beautiful and are going to have a great impact on artistic design in the next decade or so. I found what looked like black holes, and I'd like to show them to you. So what I'm going to do now, essentially, is to zoom into it, increasing the magnification manyfold, and if I press the right button, it should happen now. The computer will now.
I'm not very good at singing songs, but here's a try. If you wish to make an apple pie from scratch, you must first invent the universe. Space is filled with a network of wormholes. You might emerge somewhere else in space. Some win out in time. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature. I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky. But the brain does much more than just recollect. It intercompares, it synthesizes, it analyzes, it generates abstractions. The simplest thought, like the concept of the number one, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.
For thousands of years, people have wondered about the universe. Did it stretch out forever, or was there a limit? From the Big Bang to black holes, from dark matter to a possible Big Crunch, our image of the universe today is full of strange sounding ideas.
How lucky we are to live in this time, the first moment in human history when we are, in fact, visiting other worlds. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The surface of the Earth is the shore of the cosmic ocean. Recently we've waded a little way up, and the water seems inviting.
We're all connected to each other biologically, to the earth chemically, to the rest of the universe atomically.
I think nature's imagination is so much greater than man's. He's never gonna let us relax.
We live in an in-between universe where things change alright, but according to patterns, rules, or as we call them, laws of nature.
I'm this guy standing on a planet. Really, I'm just a speck. I'm just a speck compared with a star. The planet is just another speck. To think about all of this, to think about the vast emptiness of space. There's billions and billions of stars, billions and billions of specks.
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
Across the sea of space, the stars are other sun. We've traveled this way before, and there is much to be learned.
We're all connected to each other biologically, to the earth chemically, to the rest of the universe atomically.
I find it elevating and exhilarating to discover that we live in a universe which permits the evolution of molecular machines as intricate and subtle as we.
I know that the molecules in my body are traceable to phenomena in the cosmos. That makes me want to grab people in the street and say, have you heard this?
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
There's this tremendous mass of waves all over in space, which is the light bouncing around the room, going from one thing to the other, and it's all really there, really, really there. But you gotta stop and think about it, about the complexity to really get the pleasure. It's all really there, really, really there. The inconceivable nature of nature. To think about all of this, to think about the vast emptiness of space. There's billions and billions of stars, billions and billions of specks.
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
Across the sea of space, the stars are other sun. We've traveled this way before, and there is much to be learned.